All right, guys, in this unit, we'll be studying proportional relationships with rational numbers such as fractions and decimals and so on. And we'll also be exploring percentages. So lesson 1 is called Lots of Flags. Now, although this lesson is called Lots of Flags, we'll be revisiting scale copies and we'll also be revisiting percentages. Now, I know it's been a while since we've talked about percentages, or we might have not even talked about percentages last year in 6th grade, who knows, but today I'll be showing you guys how to find percentages. All right, guys, so this lesson first opens up with an exercise called Scale or Not. All right, so for number 1 is asking you which geometric objects are scale versions of each other. And then for number 2, it says pick 2 of the objects that are scale copies and find the scale factor. All right, guys, so what we're going to be doing is we're going to be matching. So what I'm going to do is I'm going to use a highlighter to indicate which ones are scale copies of each other. All right, of course, I'm going to start with A, and I'm going to highlight that in yellow. Now for A, I can write down the dimensions on the side because remember, when I taught scale copies to you guys, I told you guys anytime you see a grid, it's used for grafting or a tool of measurement. Now in this case, we're going to use it as a tool of measurement. So let me erase some of my mess and take some of the measurements. So the base for this triangle is 1, 2, 3, 4, 5. I'm going to count this as 6. And 1, 2, 3, 4. I'm going to count that as 4. Okay? So then for the next one, I'm looking for the triangle. Now, it could either be, B could be a scale copy, H could be a scale copy, or both. All right? So let's look at triangle B. Triangle B, the units is 2 on the side. The height is 2. And this is 3. Okay? Now, if you look at A, half of A's measurements would be 2, and half of 4 or 6 would be 3. So this one is a scale copy. So I'm going to highlight that in yellow. Now let's look at H. H says 1, 2, 3. And then the base is 1, 2, 3, 4, 5. Okay. So this makes me wonder, could this be a scale copy or not? So what I can do is I could put this in ratio form. So what I could do is put this in ratio form. I could put it in the fraction form that we use for ratios, which is 4/6, 3/5. And I could see that if they simplify to the same ratio, that means that they are scale copies of each other. So divided by 2, and this would be 2/3. Well, 3/5 is actually in its simplest form, and this simplifies to 2/3, which would be for part B. So H is actually not a scale copy. Okay? Now let's move on to the next shape, which is C, and C is this square. Well, it appears to be a square, but we're going to see. So I'm going to highlight this in blue. All right, so let's take the dimensions of this shape. So this one is 1, 2, 3, 4, 5. And I always tell my kids in my class, count the lines, not the actual, when I mean the lines, like the 1, kind of like 1, 2, 3, 4, 5. Because they have a hard time counting for some strange reason. And this, let's see, 1, 2, 3, 4, 5. Okay. And this should be 1, 2, 3, 4, 5. Okay, so all the dimensions going around is 5. Okay, they're all equivalent. All the sides are equivalent. So if something is a scale copy, that means that all the sides should be equivalent to each other. So let's look at E, which is right here. And E is 2, 2, 2, 2, which would be a scale copy. So I'm going to highlight that in blue because it is. Do you guys see another shape that could possibly be a scale copy to C and E? If you guess K, you are absolutely correct, and I'm going to highlight that in blue. And the reason why it would be K is because the sides are 3, 3, 3, 3. All the sides are equivalent to each other, which will fall true to the scale copy. Okay. Now, if you want to do the calculations or figure out how we did it, or figure out if the ratios are equivalent, 5 over 5 is equivalent to 1. 3 over 3 is equivalent to 1. 2 over 2 will be equivalent to 1. Okay? So that would be scale copies. All right, let me erase my math. If you need to reference back to the calculations, you can feel free to rewind this video. All right. So now let's look at the next shape, which is D. And I'm just going in alphabetical order. And for D, it looks like it's a rectangle. I'll be highlighting in green for D. Okay, so for D, let's take its dimensions. It's 2, 4, 4, 2. All right. What letters or which shapes would you guys want to go to? You want to go to F or I first? If you guess I, we could go to I first since it's right there. I'm just highlighting in green so you guys know what shape I'm on. I'm not saying that this is a scale copy, but I'm just highlighting in green so you guys know what shape I'm on. All right, so I is 3. And the size is 1, 2, 3, 4, 5, 6. Okay. This is 1, 2, 3, 4, 5, 6, 3. Now, if you look at the relationship of D, the width is twice as long as the height, or the base is twice as long as the height. So the base is 4, the height is 2. Well, the base for I is 6 and the height is 3. So is that half? If you guess yes, it is. Even if you wanted to put it in ratio form, 2 over 4, 3 over 6, which would kind of like relate to its corresponding sides. Okay, because what I have is basically I have their height over base, and the base would be 4 for D, and the base would be 6 for I. 2 would be the height for the D, and 3 would be the height for I. And this one will simplify to 1/2. When it simplifies to 1/2, they're both equal to 1/2. Therefore, this is a scale copy. All right. So there's one more shape I want to go check out, and that is F. Now for F, I'm going to highlight it in green because I just want you guys to know which shape I'm on. Now, if it's not a scale copy, I'm going to erase the green and put an X over it. So let's take the dimensions. So the height is 2, okay? And this is 1, 2, 3, 4, 5, 6. Uh-oh. All right, so the base is actually 3 times longer than the width. The base is 3 times longer than the height. I apologize about that. And the relationship was going in halves, so this is going in thirds. This would not be a scale copy of figure D or I. So I'm going to erase it, and I'm going to put an X over it. Okay, so the last shape that we're going to check to see which ones are scale copies is the circles, of course. All right, so I'm going to start with circle G. That's right here. Now, for circle G, we can actually measure its diameter or radius, whatever you guys want to do, but we could measure the diameter. Or, you know what? We could check the height of the circle, which is 1, 2, 3, 4, 5, 6, which will also be equivalent to the diameter. So this is 1, 2, 3, 4, 5, 6. So this would be 6, and this would be 1. This will also be 6, which technically they both will be considered diameters, because if we were to measure going across horizontal and measure going vertical, it would be like equivalent to the diameter, but that's a unit 3 reference. So needless to say, this is 6, 6. So it's almost kind of similar to the square. I'm looking for something to where the diameters are equivalent to each other, okay? So let's look at this. All right, and this would be, this one kind of goes out. This is 1, 2, and this kind of goes half. So that would be like kind of like 3, okay? Because notice that it has 2 whole lines, and this is kind of like half a line. And this would be 1, and that would be 3. So technically, it would be all equivalent. So J would be considered a scale copy. Now let's look at L. And like I said, I'm highlighting just because I want you to know that that's the shape I'm focusing on. And I could do, okay, 1, 2, 3, 4. Now this one doesn't seem like it's halfway across. This one seems like it would be 4.5. Like this is 1/4 of a line. So this is kind of like 4.5. Okay, and this would be, let's see, let's count it. 1, 2, 3, 4. And then it kind of stretches out just a little bit right here. So this is also 4.5. So each side is equivalent. Each side will be equivalent. Each diameter, or regardless of what we measure, will be equivalent. So therefore, this would be scale copies to each other. Okay. So it says pick 2 of the objects that are scale copies and find its scale factor. Okay. So I'm going to pick, I'm just going to pick the first shape that I chose, which is the triangles, which is A and B, because we kind of already talked about it. Okay. Now, depending on which one would be considered your original figure, okay? If you say A is the original figure, okay, then the scale copy will be 1/2 going to B. If you said that B is the original figure, then the scale factor would be 2. So I'm going to draw a picture and show you guys what I mean by that. So if we're going from figure A to figure B, which the size is 4, 6, just to give you guys a friendly reminder. So going from this way to this way, the scale factor would be 1/2 because it got smaller. The figure got smaller. Okay? But if we would go, and I'm going to write that in blue, if we would go this way and let B be the original figure, the scale factor would be 2. The scale factor would be 2. All right, guys. Well, if you had any issues with this lesson, make sure you visit if you had any issues with this warm-up, make sure you guys go visit your manager's Google Meet session, and I'll see you guys in the next question.